For hundreds of great shows like this one, go to onnetworks.com.
Hi, I'm Dr. Kiki Sanford, and today on Food Science, we're breaking down proteins. One of the most important processes in cooking is protein denaturation, or the breaking of a protein structure by the application of extreme conditions. Denaturation changes the structure of proteins and therefore the way that they react. Without denaturation, many delicious foods would never be possible. Proteins are necessary for our survival. We have to eat them to be able to create them in our own bodies. And to proteins, structure is everything. From their most basic to complex levels, structure determines the function of proteins. Many of the foods we eat contain proteins, which consist of amino acids. There are hundreds of amino acids found throughout nature, but only instructions for 20 are contained in our genetic code. The amino acids that organisms can biosynthesize differ. Some amino acids must be provided by diet. These are called essential amino acids. Proteins are created by connecting amino acids end to end, like the links in a chain. Then chemical interactions and bonds within the chain cause proteins to fold into knot-like formations. Proteins have 4 structural levels. The primary, chain of amino acids. Secondary is the formation of patterns within the protein. Tertiary are side chain interactions leading to the stability of single protein molecules. And quaternary is the association of multiple protein molecules or subunits. So, in uncooked foods, proteins are normally all folded up. There are an almost infinite number of possible protein structures, but the primary structure determines the final folded shape that allows a protein to perform a particular task. Change the amino acid sequence even slightly, and it might affect the structure enough to create a new protein with an entirely different function. There are different methods that can be used to break the bonds in proteins and change them from their naturally folded state, like heat or acid or force. Heating proteins increases the kinetic energy, or energy of motion, within them, so that they start vibrating more and more intensely. The amount of heat determines the amount of motion. More heat, more motion. Eventually, if enough heat is applied, the molecular motion will cause the bonds that keep the proteins folded to break. The knots unfurl and the proteins denature, returning to their primary chain-like structure. Our bodies use this strategy to rid themselves of infection. The temperature that you feel when you get sick is your body's attempt to denature viral proteins. Hopefully, the temperature doesn't get too high and end up denaturing you. Most proteins denature at 40 degrees Celsius. Higher temperatures are necessary to promote further physical changes. Adding acid to proteins, like the citric acid in lime juice, causes a change in their pH. The change in pH causes denaturation, very similarly to adding heat. Alternatively, proteins can be denatured through the physical force of stretching. This happens when you use a manual or an electric beater to whip eggs against the side of a bowl. When proteins denature, it opens up whole new opportunities for bonding. Protein chains become more likely to bond with one another and form a solid network. Water gets forced out from between the chains and a stronger, denser association is formed. The bonding of proteins into a solid mass is known as coagulation. In egg whites, the change from translucent to opaque is due to coagulation. So is the skin on the surface of curdled milk, or the increase in firmness of custard. I know this is getting a little technical, but remember, it's not just food. It's science!
For hundreds of great shows like this one, go to onnetworks.com.